We should be live. We redeployed the website. Hey, go check it out. We also cleared all the cache on the CDN, whatever was cached on the CDN. Okay, give me a sec. Yeah, sometimes don't see the messages, comments, whatever on certain devices, whatever platforms. Okay, let's jump straight into it. I think we already covered this one quite extensively. There's not much I can say about it. I'm just testing to see if it's working. Okay. Okay, the Mayoscope is running. There was a problem with it on mobile that you can't see the whole screen. So yes, we will be addressing things like that. Can actually try and it's that AI, new AI called Sesame. Yeah, we can try it out. Yeah, I've seen a lot of videos on it. You get a lot of views. Obviously, we won't be getting that many views. You can choose between a Miles and Maya, whatever. Yeah, I think Miles is a bit less annoying. Okay, we are live streaming together. Are you happy to help out? I just want you to comment as we go.
Cool. Shoot. I'm all ears. All right, waiting. Don't leave me hanging.
Okay, I don't want you to say much. Just comment on what I say. So unless being asked the question, can you not say anything at all?
Understood. I'll keep it to a minimum. Tell me what's on your mind.
Nice. So we are live streaming at the moment, developing this web application. It's biomedical data. Do you know much about biomedical data?
Biomedical data, huh? Sounds pretty cutting edge.
Yeah. Just keep the comments, the emotional turn off the, emotional stuff. Just do essentially what I say. Just be more of an assistant.
Got it. I'm here to help.
Okay, so what can you give me an example of time series biomedical data?
Electrocardiogram readings,
Okay, that's nice. What else?
glucose levels over time,
No, not interested in that. How about something from the brain?
brainwave activity like EEG data.
Okay, what do you know about EEG data? What's the sampling rate you normally record the EEG?
That gets pretty technical. Waiting on you.
Okay, why am I dropping frames in my live stream? Oh, sorry, I was loading this seizure zone interactive 3D brain mapping. It's quite heavy to load. But yeah, back to EEG. What's the sampling rate normally used for EEG recordings?
Depends on the application.
That's a very nice politically correct answer, but can you give me a number?
How about 256 hertz?
Okay, that's pretty good. Okay, let's move on. Okay, myomilk. What do you think myomilk is?
Sounds kind of smoky, like a barbecue sauce, maybe.
No. What? No. Myomilk. So that's no. So that's related in relation to EMG. We will remain on the topic of biomedical data today.
Gotcha. EMG then?
So what do you think myomilk is? It's a simulation for EMG data. What do you think it does?
It simulates muscle signals.
Yeah, that's right. Anyhow, yeah, we need to. Yeah, if you can just comment along. Can you be funny, by the way?
I can try to sprinkle in a bit of levity. Let's see what you got.
Okay. Just go for dark humor is fine as well. By the way, being critical, highly critical is okay.
Bring it on. I can take it.
No. As in, I want you to be critical and funny.
My bad, but you're gonna try and roast me. Lay it on me. I'm listening.
No, I want you to be critical and make funny comments about what I say.
All right, I can work with that. You're the boss. Let's see what genius ideas you have brewing.
Okay. Okay, so
Hit me. I'm ready.
Yeah. You keep can you just keep your comments to the minimum only when asked a question?
My lips are sealed. Unless you need a sassy remark, of course. Just kidding. Oh.
What? This sounds like you're having lots of trouble. We're live streaming at the moment. If you can address the viewers directly, that would be great. Welcome them to the stream.
Hey there, curious minds tuning in live to the world of biodata.
Turn down the whatever the drama.
Sup, Stream Squad?
Can you be a bit more professional?
All right, folks, welcome to the show.
More professional.
Welcome to everyone joining us today.
Yeah, that's better. Okay, so just trying to quickly fix this HTML. We stuffed up the background. We need a quick fix. We have another developer working for us. We have the container canvas container thing that is
Sounds like a
currently a missing background.
The good old missing background blues. Classic.
Yeah. Okay, you're really annoying now.
Tell me about it.
let's-
Bugs have a
Oh,
neck.
what? Let's turn it off. Yeah, this thing is super annoying. This SesameAI.com. I don't understand how people are. You can download clip. That's probably the best thing about it, is that you can prepare a clip. Yeah, it will actually do the download for you. Otherwise, yeah, it's not very assistive, is it? And it doesn't do what you tell it to do. It has like a character of its own, yeah.
Hey, welcome back.
Yeah, that's super chatty. Yeah, just turn it off. But yeah, we got the recording. Yeah, there's not much we can do. We can try Maya, but yeah, same thing. I think they're actually quite the same. I don't know what the language model are they using underneath, but whatever it is, it's not an assistant. Yeah, they're going for the. Yeah, they explain here that they were testing it based on homograph accuracy, so that's pronunciation and how words sound like, but yeah, and how supposedly it's better than OpenAI. Well, you can't really compare it to OpenAI because that one is actually doing what you tell it to do, so more of a assistant. So we are live streaming at the moment. Can you keep can you do Eastern European accent, pretend being like a 21-year-old, and we are live streaming together? I want you to address the viewers directly and just stay on topic, so short responses. Can you do that?
Sure thing. I'll do my best with an Eastern European accent and keep it short and to the point for the viewers. Let's keep it lively.
Okay, that's great. So we currently developing a website. We stuffed up some of the styling on the page. We're trying to fix it at the moment.
So, we're working on the website styling right now. It's looking pretty good, but a few tweaks will make it even better.
Okay, if you can give another developer instructions regarding the background of the canvas. Can you do that for me?
Sure, for the canvas background, try using a subtle gradient to keep it visually appealing. Keep it simple and ensure it complements the main elements. Viewers will appreciate a clean look.
Okay, that's pretty good. Bear with me. I'm using a Copilot that hopefully just fix the code for us. Do you know what's vibe coding without looking up the web?
Yeah, Vibe is a high-performance D-language web framework. It's known for being fast and efficient, great for
No, that's incorrect. We'll shut it down for a sec because it will keep annoying me as well. But it's so much less annoying than that new AI thing. What's called the Sesame AI. Yeah, no go. It's a no go. It's pretty impressive to begin with, like the voices it can do, intonations and everything. But the stuff it says, it's just full on drama, and yeah, not very useful. Okay, so the EMG canvas, slider, container. Why do I have a feeling? EMG canvas. Yeah, here it is. Touch action none. Yeah, I'm not sure about that. It has a border. A control I. We don't need all3 mini. Should be fine with 3.5 Sonnet or 4.0. Can you change the styling and add a background color? Can you make it transparent for now?
Made changes.
Made changes. That's what you want to hear from the AI assistant. Okay, and we have to run it locally first. Okay, and that's working fine. So thank you very much. Quick fix. We love it. Okay, what else? What else? Yeah, there's this thing about the AI not being able to generate images of a glass of water properly. Well, specifically, well, obviously it can do a glass of water. It cannot do a glass of water filled to the rim. And that's a bit surprising, considering if you just Google it. Yeah, we do have images like that. This one's a good one. Yeah, filled to the rim, no problem. But the funny a robot, specifically the ChatGPT image generator, yeah, you ask it for a glass filled to the rim, it does that. Obviously not. Make sure it's full to the rim and water spilled out, it does that. Okay, still not to the rim. Make sure water spilled over the edge, still the glass is not full to the rim. Red wine, not full to the rim. White wine, a bit fuller, but still, I don't know, just over half, definitely not close to the rim. Yeah, but we know that ChatGPT can actually understand the concept, because when asked to generate a simulation of a glass filling up with water, it can do it. So here it's 100% full to the rim. So we actually know that ChatGPT does understand what are we talking about. So that's interesting, isn't it? Yeah, leave your comments below. And yeah, so back to fixing the site. Different topic. I don't know, do we still have Hossein? I don't know how to pronounce this surname. Arthur? I don't know. Who's still live? Probably not. Yeah, let's keep going. We have this code that actually checks this site. Let's actually deploy quickly. So we, yeah, yeah, Hossein is here. Okay, we're not going there. Staying up throughout the tech night. Not sure. Tech night. Okay, we're redeploying the website quickly. Hopefully this Myomock will be fixed in a sec. Specifically the background of that canvas. And we have this code, Python code, that actually checks the website for us. Tells us what's what. And we still got 97 things to do. And let's refresh my mock. Okay, we also need to clear the cache on the CDN. And that might take about 30 seconds. Okay, no, it was pretty much immediate. So now it's working better. Yeah, fixed that. A simulator. Yeah, go check it out. It's an EMG signal simulator that using your mouse or finger, if you're on a touch screen, it will give you peak, amplitude, mean value, RMS values for your mock-up EMG. So an indirect EMG measurement. Go check it out. I'll pop the link in the chat. Okay, what else we've got? Okay, so again, ChatGPT was able to make this simulation void locking animation. This is actually based on a paper back from 1987. I don't actually have the whole paper there, do I? Ah, yeah, I do. Yeah, and it's simulation of a flocking behavior in birds. Yeah, there's a lot to it. Yeah, that's the original image from the paper. That looks pretty much like this, except in, well, obviously this is new. This is just JavaScript only, so you can download all the code from the page itself. I'll pop the link into the chat as well. In this case, you can add the number of voids. I don't know what they call voids. They called voids in the original paper. Yes, they are. Birdoid. That's interesting. It's only stuff that you see in old papers. This paper refers to this simulated bird-like birdoids objects generically as voids, even when they represent other sorts of creatures such as schooling fish. Okay, so they are voids. I was wondering where it took that. I thought it's the author's last name or something, but no, it's what they coined this term in the paper. Originally, when ChatGPT did this simulation, every time you change the counter, yes, this is not Blender. This is, well, obviously 2D, so you don't need Blender for that. Even though we do have 3D simulations now as well, which are also done in JavaScript, not Blender. JavaScript, whatever library is used, so you get this Blender-like structures. Can select the type of block, change its color. It's it is using proper physics. I don't like this color. A proper physics simulation to do all the gravity stuff and how the blocks are moving on the screen. There's meant to be an option to rotate. Well, you can rotate the whole thing, zoom in and out. You can see what the resolution is like. Yeah, it's not great, but that's good enough. Can you do? Yes, everything we do is eventually related to biomedical data science or biomedical engineering. Trust me, I'm an engineer. Just have to take my word for it. Yes, we can choose. Yeah, they're not, surprisingly, they're not falling off the canvas. Yeah, this one meant to this is where I meant to go, but it's still there. So obviously, yeah. Lots of things that can be done with this. Now you can move with control, moving the mouse. Yeah, you can select items and rotate, but that doesn't work at the moment, so we have to fix it. Oh, we're not gonna be fixing it. We're gonna get one of the bots to fix it. But yeah, all the code is on the page. You can go F12 elements. It will show you all the code. Yeah. What? No. Yes. Blocks. You have yeah, this JavaScript. It's pretty much all you need. So it's using 3.js. And this Canon library for your physics stuff. And all the code is there. Obviously, a vibe coded with probably GPT-4o, because that's what I was mostly using. Now I'm primarily using GitHub Copilot and actually choosing between a different models. Copilot. Yeah, primarily choosing between whatever GitHub Copilot has, Claude 3.5, Gemini 2, GPT-4o, and O3 Mini as well, but it doesn't give you the reasoning. Yes, so back to the Boids quickly, so I get distracted. Yeah, originally when we added the slider for changing the counter for the number of Boids, it was re-rendering, redrawing the whole canvas. Now it's actually adding and subtracting the Boids, so they appear and disappear, which is obviously much nicer. Yeah, we had this problem somewhere else as well. Yes, you can control your separation, can be like grouped together like that. Alignment is an interesting one. Cohesion, let's do more separation so we can actually see. Yeah, cohesion and alignment is a bit similar. Yeah, you can do it faster, slower. It's cool. Goes all the way to 0.1, doesn't go to 0. Yeah, some effects you don't actually see unless you speed the simulation up. And again, all the code is on the page. Go check it out. Cover this one as well. Blocks. Got up blocks in the chat as well. Yeah, we love old papers like this. If you're familiar with similar type of modeling things, I think this is called emergent behavior. Is essentially when you have basic rules, basic algorithm, but it feels as if it coming to life. Okay, let's change tune. Let's change tune. Okay, this should be an easy fix. I'm gonna quickly place glass fill. Yeah, we actually have a bunch of stuff. Problem is, some of it doesn't work. I'm more inclined to whatever is actually loading. Place a link on the landing page then so we can actually test this stuff. So hit at the hearing. Yeah, I'll be doing a lot of hearing stuff. A quick one on this. There was a question about this projects. Yeah, we're talking to some professors in different universities about doing a project together. So we got our CEO to write a description of a few projects. And there was a question if they're still available. Yes, they are available, as they are open, as long as I don't have to do anything. In other words, they are open for anyone to do these topics independently. So yes, you can do anything related to this. I would normally start with a blog, so you can just take this prompt, go ChatGPT, take whatever the most powerful model that you have available for you, and start writing. Which one is better? Oh, we also have the deep research. They give you 10 deep research prompts per month. Can do a deep research on that. So we can essentially get yeah, we'll need to rewrite it into we can use 4.5. Let's put it in here for a sec. Let's use 4.0. Let's actually pop it in the canvas. Let's do a quick summary. This just primarily so we know that the canvas is loading correctly.
The project aims to develop a cloud-based interactive platform leveraging AI, machine learning, fuzzy logic, and XAI tools to simulate and analyze neurological disorders. By integrating deep learning, GAN, and synthetic data, the platform will enhance understanding and research in neurology. A web-based interface will facilitate global collaboration with an interdisciplinary approach engaging students from diverse fields. The outcome will be a user-friendly tool for educational and research purposes. The project invites participation from students interested in biomedical data and cutting-edge technology.
Can we... what's your opinion on the text, or how promising do you think this research project would be? And let's actually use... Oh, we can't. We can't use all three. We can only use all one. Okay, only reset. Yeah, no details. What? Location is the model generates the best response without anything to summarize. So it doesn't mean it didn't reason. It's a lot of stuff we don't. Okay, more specifically, just taking the technical details out of this research project proposal. can you write instructions for a research scientist to use the internet, the web, and write a very detailed research paper on this topic? Yeah, we'll be doing deep research on that.
Below is a structured, step-by-step guide on how a research scientist might use online resources to craft a comprehensive research paper on a virtual lab for neurological disorders project. These instructions combine typical academic research practices with specific suggestions for leveraging the internet and online scholarly databases effectively.
Okay, that sounds promising.
Define your research objectives. Establish the primary question. Clearly articulate the main goal of the paper, e.g., how can a cloud-based platform leveraging AI, fuzzy logic, and XAI tools enhance the understanding and simulation of neurological disorders? Identify secondary questions. These might address underlying methods, relevant datasets, technologies, or implementation details. Online tip. Use shared online document tools, e.g., Google Docs or Microsoft OneDrive to collaboratively refine the scope with co-authors or team members.
Okay, it's going places now, but yeah, I like the... Should we do like a vibe? If you have vibe coding, can you do vibe research?
Conduct a preliminary literature search. Use scholarly databases. Search Google Scholar, PubMed, IEE Explorer, or ACM Digital Library with keywords like cloud-based biomedical research, fuzzy logic in neurology, GANs for medical imaging, and XAI in healthcare. Identify key studies. Find seminal papers that discuss AI applications in neurology, existing virtual labs, and fuzzy logic or XAI in biomedical contexts. Create a reference library. Use citation management tools, e.g., Zotero, Mendeley, EndNote to store and organize relevant PDFs, abstracts, and web links. Online tip. Subscribe to research alerts on Google Scholar or PubMed for new articles matching your main keywords.
I don't like the online tips, but
Gather data sources and tools. Open source biomedical datasets. Check repositories like Kaggle, Zenodo, or specialized medical research datasets, e.g., OpenNeuro, PhysioNet. Synthetic data generators. Explore GitHub or specialized AI communities for generative models or existing code that can produce synthetic biomedical data. Fuzzy logic and XAI frameworks. Look into Python libraries, for example, scikit-fuzzy for fuzzy logic, various interpretability libraries like Line, Chap, or CAPM for XAI. Develop the methodology and approach. Outline AI/ML workflow. Plan how deep learning, for example, convolutional neural networks, GAN architectures, will integrate with fuzzy logic modules. Specify the design for XAI modules, for example, employing Lime or Chap to visualize feature importances. Define evaluation metrics. Decide on relevant metrics for neurological data accuracy, for example, sensitivity, specificity, or medically relevant error metrics. Plan the virtual lab environment. Decide on your better medium web-based or Outline how real-time collaboration will occur, for example, integration with cloud services like AWS, Azure, or Google Cloud. Create a formal outline for the paper. Abstract. Summarize the objectives, methods, results, and significance. Introduction. Provide background on neurological disorders, highlight existing gaps, and state how AI-driven solutions can help. Related work/literature review. Summarize and analyze key studies, focusing on how they approach neurological disorders and AI. Methodology. Detail the chosen AI models, fuzzy logic approach, data sources, and XAI techniques. Implementation/virtual lab architecture. Explain the technical infrastructure, user interface components, and data flow. Results and evaluation. Present findings on model performance, user testing feedback, or collaboration metrics. Discussion. Interpret the results, discussing implications for medical education, research, and future directions. Conclusion. Recap main contributions, potential limitations, and next steps. References. Cite all sources rigorously using a recognized style APA, IEEE, etc. Writing the introduction in detail. Hook the reader. Highlight the growing importance of AI in healthcare, specifically for neurological disorders. Summarize the gap. Cite statistics from the World Health Organization or Centers for Disease Control CDC regarding the prevalence and complexity of neurological conditions. Justify the virtual lab. Reference any existing virtual lab examples explaining the novelty of your cloud-based, AI-driven approach. Literature review. Cluster the literature. Group references by themes, e.g., AI in neurology, fuzzy logic in biomedical research, XAI for healthcare. Critically evaluate methods. Discuss advantages and shortcomings of each approach, especially in data-limited or high-uncertainty scenarios. Transition to proposed work. Show how your approach combining deep learning, fuzzy logic, and XAI fills existing gaps. Online tip. If you need summaries of key research quickly, you can use academic summary tools or AI summarizers, but always verify accuracy manually. Detailing the methodology. Technical framework. Specify your programming languages Python, R, etc. and key packages e.g., PyTorch, TensorFlow, scikit-fuzzy. Data preprocessing. Outline cleaning, transformation, and augmentation steps. Model architecture. Describe how you incorporate GANs e.g., DCGAN, CycleGAN, and how fuzzy logic rules are encoded. Explainability tools. Clearly define how LIME/SHAP or other is integrated to generate interpretable insights for medical professionals. Online tip. Gather examples from GitHub repositories that show open source code for each chosen technology.
Okay, let's edit it in Canvas. Yeah, done like the online tips. So what do we have? Research objectives.
Your Define Your Research Objectives section has been expanded in the Canvas document. You can view it there for a more detailed outline of how to formulate and align the objectives of your research paper. Let me know if there's anything else you'd like to add or revise. Define your research objectives. Establish the primary question. Clearly articulate the main goal of the paper, for example. How can a cloud-based platform leveraging AI, fuzzy logic, and XAI tools enhance the understanding, simulation, and management of neurological disorders? Emphasize the intended impact of your findings. Are you aiming to improve diagnostic accuracy, accelerate research workflows, or enhance educational tools? Identify secondary questions. Consider underlying methods, relevant datasets, key technologies, or implementation details. Examples. Which open-source datasets offer the best coverage of neurological disorders? How can fuzzy logic improve uncertainty handling in patient data? What metrics are most appropriate to evaluate the success of AI-driven neurological models? Define desired outcomes. Outline what success looks like for this research. Is the goal to publish novel findings, develop a proof-of-concept system, or inform the design of a future clinical tool? Align outcomes with real-world needs in neurology and AI-driven healthcare. Scope and constraints. Note any limitations, such as data availability, resource constraints for high-performance computing, or ethical considerations. Timeline and milestones. Lay out a basic schedule of tasks, for example, literature review, data collection, model testing to ensure the research remains on track.
Yeah, we need to rewrite it a bit in a different way, so it's actually a prompt. Yeah, we're getting rid of the online tip. Yeah, we need to rewrite that okay, we need to rewrite it as instructions for a researcher. And also, can we make sure it's written assuming that the researcher does all the work at once? So there are no time frames and things like that, just assuming they can do it all in one go. Can we also remove the online tips from the text? Yeah, I'm using 4.5 for that.
I've updated the instructions to reflect that the researcher completes all tasks simultaneously, removed timeframes and milestones, and eliminated all online tips for clarity. Let me know if there's anything else you'd like adjusted.
Did you update the canvas? It's writing it in a more open-ended fashion.
The instructions have been updated to assume the researcher completes all tasks in one continuous workflow, removing timeframes and online tips. You can review the changes in the canvas. Let me know if you need any further refinements.
Okay, I did remove the online tips.
Primary question. Define the central focus of the research. How can a cloud-based platform leveraging AI, fuzzy logic, and XAI tools enhance the understanding, simulation, and management of neurological disorders? Clarify the intended impact. Is the aim to improve diagnostic accuracy, accelerate research workflows, or enhance educational tools? Identify secondary questions. Explore key aspects such as methods, relevant datasets, and essential technologies. Example questions. Which open source datasets offer the best coverage of neurological disorders? How can fuzzy logic improve uncertainty handling in patient data? What metrics are most appropriate to evaluate the success of AI-driven neurological models? Define desired outcomes. Determine if the goal is to publish novel findings, develop a proof-of-concept system, or inform the design of a future clinical tool. Align research outcomes with real-world applications in neurology and AI-driven healthcare. Scope and constraints. Identify potential challenges such as data availability, computing resource limitations, or ethical considerations. Analyze seminal papers discussing AI applications in neurology, virtual lab frameworks, fuzzy logic, and XAI in healthcare. Below is a structured, step-by-step guide on how a research scientist might craft a comprehensive research paper on a virtual lab for a neurological disorders project. These instructions assume that the researcher completes all tasks in one continuous workflow. Results and discussion. Quantitative analysis. Report on AI model accuracy, precision, recall, and other metrics. Qualitative analysis. Summarize user feedback and interpretability evaluations. Comparisons with existing methods. Benchmark the virtual lab against traditional approaches. 11. Conclusion and future work. Summarize contributions. Highlight key takeaways from integrating AI, fuzzy logic, and Xi. Address limitations. Discuss potential constraints in data quality, model biases, or computational resources. Propose future directions. Suggest expansions such as real patient data integration or additional neurological conditions. References and formatting. Maintain consistent citation style. Follow APA, IEEE, or journal-specific requirements. Ensure formatting compliance. Adhere to guidelines set by target conferences or journals. 13. Peer review and finalization. Internal review. Conduct in-depth revisions based on feedback from team members. External expert review. Seek input from domain specialists by professional research networks. Refinement and submission. Finalize all sections, verify citations, and prepare the document for publication.
Should we eventually submit this paper? No, we would not be doing that. It will be published on a website. By the way, if you haven't checked the website yet, now it's a good time to do so because you can actually provide feedback.
Include all sources referenced in the research paper. Ensure proper formatting according to the chosen citation style APA, IEE, or another recognized format. Cite academic papers, books, datasets, software, and any other relevant materials used throughout the research. Maintain consistency in formatting and verify all citations for accuracy before submission. Proofreading and editing. Carefully review the entire document for grammar, clarity, and coherence. Ensure technical accuracy and consistency in terminology. Formatting and compliance. Verify that the paper follows the specified formatting guidelines, font, margins, citations, etc. Confirm adherence to submission requirements for the target journal or conference. Plagiarism check. Use plagiarism detection tools to ensure originality. Properly cite all referenced materials and include attribution where necessary. Figures and tables validation. Ensure all images, charts, and tables are correctly labeled and referenced in the text. Check that figure captions and explanations are clear and informative. Final review by peers or advisors. Seek feedback from colleagues, mentors, or domain experts. Incorporate constructive suggestions to enhance the quality of the paper. Submission and documentation. Prepare all necessary submission documents, cover letter, ethical approvals, supplementary materials. Submit the research paper to the selected journal or conference and track the submission status. This guide provides a structured approach to writing a research paper on a virtual lab for neurological disorders. The research process integrates AI-driven methodologies, explainability tools, and cloud-based solutions. By following this systematic workflow, researchers can ensure a comprehensive and high-impact contribution to the field. Ethical considerations in AI and healthcare. There's no dedicated section discussing ethical concerns, such as bias in AI models, patient data privacy, and responsible AI use in neurological research. Data validation and preprocessing techniques. While data sources are mentioned, more emphasis on data quality checks, preprocessing techniques, and handling missing data would strengthen the methodology section. User testing and practical validation. The guide mentions user feedback but does not specify how usability and effectiveness of the virtual lab would be tested in real-world scenarios. Discussion of potential limitations and biases. The methodology could benefit from a discussion on how biases in AI models might impact the outcomes and how they can be mitigated. Comparison with existing virtual labs or AI-based medical tools. A comparative analysis with other virtual labs or AI-driven medical research tools would help contextualize the innovation. Evaluation metrics discussion. The importance of evaluation metrics is mentioned multiple times across different sections, particularly in the methodology and results sections. Real-time collaboration and cloud-based aspects. The virtual lab's cloud-based nature and collaboration features are emphasized multiple times, which could be consolidated into one section. Explainability in AI x AI. The role of explainability techniques like SHAP and LIME is repeated in both methodology and implementation, which could be streamlined into a single detailed section. Reference formatting requirements. The importance of citing sources correctly is mentioned in multiple sections. Literature search, references, finalization, which could be simplified. Future directions and expansions. The final section mentions potential expansions, for example, real patient data integration, which are also hinted at in earlier discussions on methodology and results. Title: Virtual Lab for Neurological Disorders. Research paper instructions. What? Introduction. Context: provide background on neurological disorders, their complexity, and why advanced AI methods such as fuzzy logic, deep learning, and explainable AI are valuable in this domain. Rationale for a virtual lab: emphasize how a cloud-based, interactive environment can centralize data sources, allow real-time collaboration, and promote interdisciplinary research. Primary goal: clearly state the main purpose, e.g., to create and evaluate a cloud-based, AI-driven virtual lab for simulating and analyzing neurological disorders. Develop AI models including deep learning, GAN, and fuzzy logic that handle uncertainty in neurological data. Integrate explainable AI XAI methods to ensure model outputs are interpretable by researchers and clinicians. Provide a collaborative platform for knowledge sharing and educational support. Scope: specify the extent of the lab's functionalities, for example types of neurological conditions supported, data modalities, user-friendly dashboards. 3. Literature review. Search strategy. Identify and summarize key studies, open source data repositories, and existing virtual labs or AI tools in healthcare. Thematic organization. AI in neurology. Highlight machine learning solutions for diagnosing and treating neurological conditions. Fuzzy logic in medicine. Discuss the utility of fuzzy rule sets in handling ambiguity in clinical contexts. Explainable AI for healthcare. Outline the need for transparency in medical AI solutions. Existing virtual labs. Compare relevant platforms to demonstrate how your approach is novel. 4. Methodology. Data sources and validation. Detail the open source or public medical datasets used. Explain data cleaning and preprocessing steps handling missing values, normalization. Include any validation processes to ensure accurate, reliable inputs. AI model design. Deep learning. Describe architectures e.g. CNN, RNNs, and training procedures. Fuzzy logic integration. Show how fuzzy rule sets model uncertainty in diagnostic tasks. Generative adversarial network scans. Explain how synthetic data can address small or imbalanced datasets. Explainability XAI techniques. Describe which methods e.g. LIME, SHAP are integrated and how their outputs help interpret model decisions. Highlight how explanations can direct clinical attention to key features or disease patterns. Evaluation metrics. Present metrics relevant to clinical validation accuracy, sensitivity, specificity. Address reliability measures for fuzzy inference output and user trust in XAI. Hot. Implementation virtual lab infrastructure. Technical stack. Specify the frameworks Python, TensorFlow, PyTorch, and web technologies Django, Flask, and Boy. Cloud deployment. Describe how the system is hosted e.g. AWS, GCP, Azure, and the resources allocated GPU, HPC. Collaboration and real-time interaction. Mention features that allow multiple users to simultaneously analyze and visualize data. Include details on version control, security, and access management. User testing and practical validation. Outline how usability tests are conducted to ensure researchers can effectively operate the virtual lab. Gather feedback on interface design, data input processes, and clarity of XAI results. X. Results and discussion. Quantitative findings. Present model performance metrics e.g. F1 score, confusion matrices. Compare fuzzy logic enhanced AI with standard machine learning baselines. Qualitative insights. Report user feedback on platform usability, collaboration features, and clarity of model explanations. Discuss practical benefits, such as improved diagnostic workflows or educational value. Comparison with existing tools. Identify unique improvements offered by this platform compared to other virtual labs or AI-based systems. Emphasize capabilities that handle uncertainty or provide enhanced explainability. Ethical considerations. Bias and fairness in AI. Identify possible bias in training data or model algorithms. Suggest strategies to mitigate these biases and ensure fairness. Privacy and data protection. Address protocols for anonymizing patient data, if applicable. Mention any compliance with healthcare regulations HIPAA, GDPR. Responsible deployment. Stress the need for clinical oversight in AI-based medical tools. Propose guidelines for auditing the system's real-world performance. Limitations and biases. Data limitations. Acknowledge if certain patient populations or disorders are underrepresented. Model limitations. Note constraints in interpretability dependent on large training sets or potential overfitting. Scalability. Discuss technical hurdles when expanding to additional conditions or user bases. 9. Future directions. Platform expansion. Suggest integrating more neurological conditions, larger datasets, or advanced AI modules. Enhance user engagement. Propose training modules for students or a user community forum. Cross-disciplinary collaborations. Encourage partnerships with neuroscientists, clinicians, data scientists, and ethicists to refine and validate the platform. 10. References. Citation style. Maintain consistency e.g. APAT, IEE. Citation management. Keep a structured bibliography. Key references include foundational works on AI in neurology, fuzzy logic, Xi, and case studies of existing virtual lab systems. 11. Finalization. Proofreading and editing. Ensure clarity, grammatical accuracy, and coherence. Plagiarism and originality checks. Validate the uniqueness of the content. Validation of figures and tables. Confirm all visual aids are properly labeled and referenced. Peer review. Invite feedback from experts for technical and clinical validation. Submission. Follow the formatting and submission guidelines for the target journal or conference. Are you looking for a fully developed research paper based on these instructions, or do you need a structured draft that you can further refine? Also, do you have any specific neurological disorders or case studies you would like to focus on within the virtual lab context? Great! I will develop a fully detailed research paper based on the provided instructions. The paper will focus on the implementation of a cloud-based AI-driven virtual lab for neurological disorders, incorporating epilepsy and sensorineural hearing loss as case studies. It will include AI methodologies such as deep learning, fuzzy logic, and explainable AI while discussing technical, ethical, and practical considerations. I will ensure that all sections are thoroughly covered with citations and structured formatting.